In this video, I want to answer the question of what is a union, and not only do I want to answer the question, but I want to justify why I'm even bringing the question up in the course here, okay? First of all, a union allows two variables to share the same memory. And yes, you heard right and you read right. Two variables, x and y, share the same memory location and they overwrite each other, okay? Now I know what you're thinking. What could possibly go wrong with this kind of scenario? And of course the answer is, thanks to your sarcastic question, a lot can go wrong with this. We can very easily lose control of this, overwrite our data with the wrong data, create all kind of logic errors in our program and so forth. All right, and so what's the reason that people would do this? Well, let's take a little history lesson here, okay? And before I do that, the reason I'm even bringing this whole sordid affair of a union up is because you're still going to see these. C++ has been around a long time, and a lot of the old timers wrote this way. Why? Well, it dates back to the days when we all used to have to walk to school in the snow, uphill both ways, and all those sad stories that we heard. Because back in those days, boys and girls, our computers only had, 64K of memory. Remember the Commodore 64, the Texas Instruments TI-99-4A, and all those kinds of things only had 64K of memory. Well, if you're coding in that environment, you had better really do everything you can to conserve memory, or you're going to have a problem. And if you have a memory leak with only 64K of memory, you've really got problems, okay? So when you're writing code for those types of environments with computers that only had 64K, you had to do everything you could to conserve memory. So obviously we're not there anymore. We now have gigabytes of RAM on our machines. Why would we want to mess with these things? Well, it allows two variables to require half as much memory space, all right? And that's not that big a deal anymore with all the memory we have, but one can utilize the memory space when the other one's finished with it without having to initialize the variable and all that. So you can eke out just a little performance gain there. So that may be one reason you would use it now. The next one is if you're not sure what data type will be required, since two different data types can share the same memory, right? Notice at the top I said two variables. Now I'm kind of adding to the plot here. Two different data type variables can share that same memory space. Then again, I can save a little bit of overhead by just simply plugging data in there without having to create a whole new type. Okay, so here's the bottom line though. You can use dynamic memory allocation now since we've got gigabytes of memory available to us, and it's usually a better solution. Notice the word usually. You could come across instances where you need to use a union, and I just wanted you to be aware of this. You can use the new keyword when you create your objects, and it will place them on the heap. Now if you use the new keyword, you have created dynamic memory allocation. Everybody's got their own memory address. Everybody comes into existence. Everybody's using pointers. Everybody's happy. The only thing, if you use that new keyword, you need to use a destructor when you're through with that object, or it will never come off the heap. And in essence, you're leaking memory, tying up memory you can't get back to and free up, and memory's leaking away from availability to everything else on the computer. Now, when you've got a couple of gigabytes of RAM available, this usually isn't that big of a problem. However, it can become one. All right. So what does a union look like? And I want you to see this because, again, a lot of us old-timers are still in our old habits, and we'll still use unions because we've always used them. Or you may just open up old code that you're having to enhance or rewrite or correct or whatever, and you may see these unions in there. Well, this is what one looks like. You'll see the keyword union, and then you will create the union. It's called long and short. And notice you'll kind of lay it out here. It's got an X, a variable in there called X. It's a data type of long, a variable of Y, with a data type of short. And then, much like a class, we can just give it an instance name out here, okay? Or you could just create this as an instance, union X of the type, both long and short. But that's what you end up with, and then to access it, you just call union x.x or union x.y. Now, if I set union x.x equal to 2, it overwrites whatever in y or x, and then if I set y equal to 3, it overwrites it, and my union x value is going to be the y, and it's equal to 2. All right, so play with this if you would like. I just wanted you to be aware of it. Stay away from it generally. It can be problematic, but it is a tool. You need to know about it. You could see it in old code, and I just wanted to bring it to your attention. I'm not going to do any examples on it or anything. Just want you to be aware of it and know what you're looking at when and if you see it out there.